Hello students, in today's session of NCERT chapter Permutation and Combination, further very basics will be cleared through illustrations taken from exercise NCERT exercise 7.3. Exercise 7.3. In today's session, we are going to discuss further when FPC of multiplication is applicable, when FPC of addition is applicable. FPC means fundamental principle of counting is applicable, right? It is requested go through the complete session, going to be very important in respect of concept killing, right? Please go through the session completely. Now let's start with the concept and questions. Now before start of the question, some basic theorems will be discussed which are applicable in the session. What is fundamental principle of counting? Counting is of two types, counting of multiplication and counting of addition. When this is applicable, when this is applicable. Multiplication is applicable if an operation can be performed in n different ways, following which a second operation can be performed in n different ways, then the two operations in succession can be performed in m into n ways. This can be extended to any finite number of operations, right? One is addition. If to perform an event, number of methods are there, then all the methods are to be, number of ways of method are to be added. If an operation can be performed in m different ways, another operation which can, independent of the first operation, can be performed in n different ways, then either of the two operations can be performed in m plus n ways, right? These concepts have been cleared in session very basic 1, which you can review on sethiswiftlearn, right? Now let's start with the concept and questions further, right? To clear the concepts, illustration being taken from NCERT Exercise 7.3, right? Question is, how many three-digit number can be formed by using the digits 1 to 9 if no digit is repeated? Concept applicable and solution. Total number of digits is are 9. 0 is not there. Repetition allowed or not allowed? Not allowed. Not allowed. Means one number utilized cannot be used again. To form 3-digit number. 3-digit number. So there will be unit place, 10th place, 100th place. Can be filled up. Can be filled up. Unit place can be filled up in total digits are 9 to 9 ways. कोई condition नहीं. Repetition is not allowed. Means one number utilized here, balance will be 8. It can be filled up in 8 ways. No, repetition is not allowed, so 7 ways. Right? Therefore, by FPC of multiplication, total possible 3-digit numbers formed will be 7 into 8 into 9. That comes out to be 504 number. That is the answer. FPs of multiplication means to complete an event. Number of sub-events are there, then all the sub-events are to be multiplied. Here the 3 sub-events are there. To fill up unit place, to fill up 10th place, to fill up 100th place. Event will be completed when all the 3 places are filled up. Their possibility range will be 7 to 8 into 9, that is 504 ways. That is the answer. Right? Next question. Question is, how many 4-digit numbers are there with no digit repeated? No digit repeated. Now, concept applicable in solution. Number of digits are specifically not mentioned, then there will be 0 to 9. That is 10 numbers. That is 10 numbers. To form 4-digit number. That is unit place, 10th place, 100th place, 1000th place. These are the places. These are places. Can be filled up. Can be filled up in. Because 0 is also there. So first of all we will fill up this one. This can be filled up in 9 ways. If we consider 0 here, then it will become 3-digit number. 9 ways. Now one number is utilized here as repetition is not allowed. Then balance will be 9. This can be filled up in 9 ways. This can be filled up in 8 ways. This can be filled up in 7 ways. Right? By FPC of multiplication. Total possible number of 4-digit number with no repetition of digits. No repetition of digits will be 9 into 9 into 8 into 7, that is 81 into 56. That comes out to 4536. That is the answer. In this case, point to be noted is 0 case. If 0 is there, then you have to first of all fill up with the extreme maximum value place, that is the 1000 place, right? Next question. Question is, how many 3 digits even number can be formed using the digits 1, 2, 3, 4, 6, 7? If no digit is repeated. Concept applicable and solution. Number of digits given. 3, 6 numbers. Repetition not allowed. Means one number utilized will not be used again, one less kar denge. And condition, even number, 3 digit. Now 10th place, 100th place, 10th place, 100th place. Condition is even number. To satisfy even number, condition, unit place should be even number. Then it will be divisible by right? How many even numbers are there? Total even numbers are total even numbers are 2, 4, 6. 2, 4, 6. Three numbers. No. Therefore, 10th place, unit place, 10th place, 100th place can be filled up. First of all, we will fill up. 0 is not there, so we cannot. This can be filled up in three ways. One we utilize here. Total are 6. Total numbers are 6. 5 ways. And 4 ways. Therefore, by FPCO multiplication, possible 3-digit numbers. 3-digit numbers, even number and repetition is not allowed, is equal to 4 into 5 into 3, that is 60 ways. That is the answer. Right? Next question. Question is, find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. There are two parts. How many of these will be even? Yani ki we have to form two parts of there. 4-digit number and second part is 4-digit even number. Repetition in both cases. Repetition in both cases not allowed. Right? Now, first case, unit place, 10th place, 100th place, 1000th place. First place, second place, third place, fourth place can be filled up in. How 0 is not there, no condition. 5 ways, 4 ways, 3 ways, 2 ways. Total by FPCO multiplication. 5 into 4 into 3 into 2, that is 120 ways. First part का आंसर आ गया 120, right? Second में 10th place, unit place, 10th place, 100th place, 1000th place. Even digits. Even digits are 2 and 4. Two digits are there. This can be filled up in 2 ways. One utilize there 4 ways, 3 ways, 2 ways. So therefore, by FPCO multiplication, so 2 into 3 into 4 into 2 ways, that is 48 ways. That is the answer, right? Next question. Before start of the next question, I would like to say that these concept killing videos are very helpful, useful for 11th standard, 12th standard, CBSE board, state boards, JEE, CUET, and other entrance examinations. Concerned may visit and review the same. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर आपने अभी तक YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज subscribe it and share with your colleagues and friends. Now let's start with the question. Question is, form a committee of 8 persons. In how many ways can we choose a chairman and vice chairman, assuming one person cannot hold more than one position? Here is event is to form committee, to form sub event 1 है, sub event 2 है, to select chairman, to select vice chairman. Event will be completed when this is completed, this is then by FPC multiplication, this into this will be the event completed. This can be written 8 ways, this can be written 7 ways. And this meaning here, repetition is not allowed. Repetition is not allowed. Therefore, by FPC of multiplication, so 8 into 7 ways, that is 56 ways. Answer. Right? Next question. Next question is n minus 1 P3 and this is only NP4 equal to 1:9. Find the value of this. So the concept of NPR n minus n factorial upon n minus r factorial. So n minus 1 factorial upon n minus 4 factorial हो जाएगा. n minus 1 minus 3 n minus 4 factorial upon n factorial upon n minus 4 factorial. This comes out to be 1:9. This goes, right? On simplification, this comes out to be n minus 1 factorial upon factorial n equal to 1:9. General tendency is to reduce higher factor into lower factorial. So n minus 1 factorial upon n into n minus 1 factorial. We can stop at the position of requirement, that is equal to 1/9. This goes n equal to 9. That is the answer. Right? Next question. Question is, find the value of r if 5pr equal to twice 6pr minus 1. Concept applicable in solution. npr equal to factorial n upon n minus r factorial. Right? So this can be written as factorial 5 upon 5 minus r factorial equal to twice into factorial 6 upon 6 minus r plus 1, 7 minus r factorial. Right? General tendency is to reduce higher factor into lower factorial, higher factor into lower factorial. So this can be written as factorial 5 upon 5 minus r factorial equal to 2 into factorial 6 into factorial 5 upon, this is one term, minus 1 करेंगे, 7 minus r, 6 minus r, 5 minus r factorial. Whatever this is, 5 has a 5, 4, 3, 2 like this. 7 minus r is the one term. Minus 1 we will get 6 minus r. Minus 1 we get 5 minus r. Right? So this goes, this goes. This goes, this goes. Remaining is, this comes out to 42 minus 7r minus 6r plus r square equal to 12. R square minus 13r plus 30 equal to 0. R minus 10, R minus 3 equal to 0. Then R equal to 10 or 3. Out of this, one is to be selected, one is to be rejected. NPR is defined when R is less than equal to n. उससे greater नहीं हो सकता. तो 5PR, R cannot be greater than 5. So R cannot be, so this is greater than 5. So R equal to 3. This is rejected. This is acted as N is less than equal to greater than equal to R always. Right? Now, so our answer will be here R equal to 3. Similarly, you can find the answer of this question. Right? Answer of this question is 4. R equal to 4. Right? Next question. Question is how many words with or without meaning can be formed using all the letters of the word equation, using each letter exactly once. Concept applicable in solution. Equation. Total letters are 1, 2, 3, 4, 5, 6, 7, 8. Repeated. Repetition is there? No. There is no repetition. Each letter is coming one time. Using a category, repetition is not allowed. Repetition is not allowed. This repetition is entirely different. Whether the letters are being repeated here, and each दो दफा आ जाए, Q एक दफा like this, means you have to use 8 words. We have to form with or without meaning. So how many places there are? 8 places are there. So 8 places can be filled in 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 way. Possible answer will be 40320 ways. That is wrong. Answer. Right? Next question. Question is how many words with or without meaning can be formed from the letters of the word Monday, assuming that no letter is repeated. Given word is Monday. Total letters 3 MONDA, 6 letters. Total letters 6. Right? Now, all are distinct. All are distinct. Repetition is not allowed. Repetition is not allowed according to question. First part. Four letters are used at a time. 4 letters used at a time. 4 letters used at a time. So 6 into 5 into 4 into 3. FPSO multiplication 30 into 12, 360 ways. Another way is 6p or factor 6 upon factor 2 into, this will come to 6 into 5 into 4 into 3 into factor 2 upon factor 2 cancel out. This is the first part answer. Second part, all letters are used at a time. Means 6 into 5 into 4 into 3 into 2 into 1. That is 720. That is 6p6. Factor of 6 upon factor of 0. That is 720. That is the answer. All letters are used, but first letter is vowel. All letters are used, but first letter is vowel. Means how many vowels are there? Number of vowels are 2. So this can be 2 ways. Balance 5 into 4 into 3 into 2. Right? Into 1. 5 into 4, 120 into 2, 240 ways. This is condition for vowels. In all cases, you have to apply FEC of multiplication, or you can write NPR. NPR applicable. NPR is applicable when out of n distinct objects, R objects are to be arranged, where order is concerned. Then NPR is applicable, right? Next question. Question is, in how many ways of the distinct permutation of the letters in Mississippi do the four I's do not come together? Letter is M I double S I double S I double P I. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total letters are 11. All are distinct? Distinct? No. Then this formula will be applicable. Then total divided by the repetition. This is the total divided by the repetition. Repetition 1, repetition 2, repetition 3, like this. So all are not distinct. How many S are there? S are 4. I's are 1, 2, 3, 4. 4. Any other repetition? Double S, double P. P is 2. Or M is 1. Total over 11. So, not together. 4 I's not together. Together means total minus together. Total means without any condition we have to make the permutation. Total are 11 divided by repetition. Factorial 4 into factorial 4 into factorial 2 into factorial 1 minus together. If we consider these together, so total are 11. 4 I's together, so pending are 7. 1 plus 7, 8. We have to arrange 8. 1, 4 I's are together, so factorial 4 into factorial 2. Total minus divided by the repetition. On simplification, this comes out to be 34650 minus 840. If you subtract it, 33810. That is the answer. When repetition is there, means all letters are not distinct, then this formula is applicable. Total divided by the repetition. Repetition is S as 4, factorial 4. I's are 4 divided by factorial 2. P's are 2 divided by factorial 2, like this. Right? This is the answer. Next question. Question is, in how many ways can the letters of the word permutations be arranged if three conditions? Vowels start with P and end with S. Vowels are together. There are always 4 letters between P and S. Concept applicable and solution. Number of problems and all objects are not distinct. Total divided by the repetition. Factorial. Right? Now either permutation. Permutation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12. Repeated T is 2. T is 2 there. Baki all are single. Vowels are A, E, I, O, U. A, E, I, O, U. 5 letters. All the 5 vowels are. First condition is start with P, S. So total will be factorial 10 upon factorial 2. Total divided by repetition. Repetition is only P's are 2. If we simplify it, we get the answer of first part, that is 181, 181, 4400, 4400. Vowels are together. Part 2, vowels are together. Vowels are together means A, E, I, O, U. Consider 1, 7 remaining, 7 plus 1, 8. In this case, repeated are 2, repeated are 2. So total will be 8 factorial divided by 2 factorial into factorial 5. These can be arranged in 5 ways, factorial 5 ways. On simplification, we get the answer 2419200. This is the answer, right? And third part is there are always 4 letters between P and S. P and S. 1, 2, 3, 4. This is 6. Remaining are 6. 5, 1, 2, 3, 4, 5, 6, 12 तक जाएंगे हम, ठीक है? तो P and S की जो पोजीशन होगी 1, 6 हो सकती है, 2, 7 हो सकती है, 3, 8 हो सकती है, 4, 9 हो सकती है, 5, 10 हो सकती है, 6, 11 हो सकती है, 7, 12 हो सकती है. 7 ways तो ये हो गए, 7 ways ये हो गए, right? Means P and S. So factorial 10 divided by factorial 2 into 7 into 2. 7 into 2. These are the possible 7 cases, P and S. In between P and S, it is not mentioned P should be at first. In between P and S. So 2S or P or P and S can be there. On simplification, we get 254,016,00. That is the answer. Right? This question is based on when all objects are not distinct. This is the case. When vowels start with P and S, total 10, P is this, S is. इसमें clear mentioned है, P starts से करना, S end से करना. Vowels are together, we consider vowels together, and in the last case, there are 4 letters repeated between P and S. We form all the possible positions of P and S. 7 ways is there, and they can interchange S and P. 2 ways are there, and factorial 10 divided by factorial 2 already was there. Right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.